So we have one last item here on the inverse function handout, and it has to do with composition of functions. If we compose a function with its inverse, then one function undoes the other, and we end up back where we started from. Well, if you plugged in x and applied a function and then the inverse, you'd end up back with x after composing those functions. And that's what this statement is saying here. F inverse of f of x is x for all x. If you compose an inverse with a function, you get x. You're back to the x you started out with. And it also applies in the reverse order for composition. F of f inverse of x is x for all x. Is for all x in the domain of the inside function. So we just want to go ahead and verify this and exercise. So we're going to do exercise 7, the last exercise for us to do together on this handout. And here we go. So 7a, I have recopied on a sheet of paper. And so here we want to verify f inverse of f of x is x and f of f inverse of x is x, where f is this function, f inverse is this function with restricted domain, and we don't have to verify that. All that's just given for us. We just need to start doing this composition calculation with these functions involved. So now this takes us back to composition. We're going to replace f of x with its expression, which is square root of x plus 3. And then I want to apply the inverse function to what I have here. So if I said f inverse of the box, that would be box minus 3 squared. What we happen to have in the box is square root of x plus 3. I never draw these boxes big enough. Square root of x plus 3. Okay, so you don't have to write this down each time. Just trying to remind you of that idea. So I have to take, again, I'm applying this function, so I'm going to take square root of x plus 3 minus 3 in parentheses squared. And what I have inside here, the plus 3 minus 3 cancels. I'm left with just square root of x. Square root of x squared is x. We just verified that one requirement, the first of the compositions. Now we want to do that in reverse order. And so I'm going to place inside, sorry, I just wrote the same thing down, not the reverse order, so let's try again. We want f of f inverse of x, the reverse order. And so I'm going to place inside f inverse of x, the expression for f inverse of x is x minus 3 squared. So I'm going to apply the function f to that. Well, again, the function f of box from up above is square root of box plus 3. Okay. So if I happen to have x minus 3 squared in there, which I just can't get myself to draw this box big enough, I'm going to end up with the square root of x minus 3 squared plus 3. Okay. Now, here's a subtle thing. Square root of a square, because this is always a positive square root, when you take a square root of a quantity squared like that, officially you end up with absolute value. And it's okay if you don't see that when you do this problem. Here, the domain of f inverse is square bracket 3 to infinity. So we know x is greater than or equal to 3, which means x minus 3 is greater than or equal to 3 minus 3. So x minus 3 is greater than or equal to 0, which means if this quantity is positive or 0, it's equal to its absolute value. So don't worry about that step if you don't get it. It's a technical point and not crucial. And so the absolute value bars go away. Really, square root of the square for this situation really is just x minus 3. And we end up with x. So we did part A. Let's go ahead and do part B. So we have two different functions that we're working with here. Again, we're being told one is the inverse of the other. We haven't figured that out. We're just going to believe them. And I'm going to plug into the composition. I have f inverse of f of x is x over x plus 1. And now I need to apply f inverse to this function. Now I am going to try to draw my box real big. There we go. So f inverse of box is box over 1 minus box. If this is an x over x plus 1, then this is an x over x plus 1, and this is an x over x plus 1. I got a big mess. I have a complex fraction. X over x plus 1 over 1 minus x over x plus 1. So a good little algebra problem for us to work on here now. And I like to think of complex fractions as division problems. X over x plus 1 divided by 1 minus x over x plus 1. But if I write it this way, I need to remember to put parentheses around that those complicated denominator terms. And I want to be able to, I have to combine the two terms in parentheses before I divide. So this 1, I'm going to write with the common denominator of x plus 1. I can think of that as an x plus 1 over x plus 1, right? So I have x over x plus 1 divided by x plus 1 over x plus 1 minus x over x plus 1. Whew. Recopying x over x plus 1 divided by, now I can combine into a single fraction, x plus 1 minus x all over x plus 1. And I think that simplifies a little bit because x minus x leaves me with just 1 over x plus 1. And finally I can do the division. X over x plus 1 times, I'm going to invert and multiply, right? Take the reciprocal of the second and multiply. And the x plus 1's cancel. I have x over 1. And there's my x. All right. That's half the problem. We still have the other half to do. So that was the f inverse of f of x for these two functions that we were given. There's the steps and a result. So now I got to do the reverse of that. So I'm going to try to bring back the beginning of the problem. And I want to write down the reverse. I want to do f of f inverse of x and see what happens. I hope this is no worse. I'm not optimistic. I have f of, plugging in f inverse, that's x over 1 minus x. And now I have to apply the f function to that. And f of box from here is box over box plus 1. So if I happen to have x over 1 minus x, it's got to go here. And it's got to go here. So this is what I'm trying to write down now. Another complex fraction, right? I got x over 1 minus x over x over 1 minus x plus 1. I should put my equal sign a little lower. And it's this baby that I have to try to simplify. Again, I like to think of it as division. I need parentheses, because I have two terms in that denominator, and I need to combine these. Here, my denominator is 1 minus x, so the 1 I want to think of as 1 minus x over 1 minus x, right? So I'm recopying plus, and here I'm going to write 1 minus x over 1 minus x. So it's very similar to what we just did, but just different enough that it isn't quite the same. I can add x plus 1 minus x over 1 minus x. I have x over 1 minus x divided by, something very similar happens. X minus x is gone. I have 1 over 1 minus x. And now I can invert the second fraction, 1 minus x over 1, and multiply. And sure enough, 1 minus x cancels. I have x over 1, which is x, which is what we were trying to verify, that we would get that through this composition. So that's a good little bit of algebra that everybody should be able to handle. Both parts of this one. And we are totally through with inverse functions with this exercise.